There's always been a debate about whether life could exist on Mars, and NASA fueled it all over the past couple of weeks, hinting something historic has been found on its first ever chemical testing of soil on the red planet.
NASA's Perseverance rover discovered organic molecules in Martian soil samples. These aren't just random chemical compounds. They're the exact building blocks of life as we know it. The concentrations are impossibly high, and the molecular patterns match precisely what biological processes create on Earth. Yet NASA refuses to use the word life. Their official statements dance around the discovery with careful scientific language, never crossing that line into confirmation. Why the institutional caution? Because confirming life on Mars would fundamentally rewrite humanity's understanding of our place in the universe. When Perseverance landed in Jezero crater in February 2021, it carried the most sophisticated organic detection equipment ever sent to another planet. The sample analysis at Mars Instrument was designed to identify the molecular fingerprints of ancient life. What it found defied expectations. Complex organic molecules, thiophenies, benzothiophenies, and naphthalene, scattered throughout the Martian soil in concentrations that shattered previous detection records. On Earth, these exact molecular signatures appear exclusively in biological contexts. They're the chemical fossils left behind when living organisms decompose over geological time. The isotope ratios tell an even more compelling story. Carbon-12 to carbon-13 ratios in these Martian samples show the distinctive preference that biological metabolism creates, the same signature found in Earth's oldest fossilized life forms. But here's what makes this discovery impossible to dismiss. The molecular complexity increases with depth. Deeper samples contain more sophisticated organic structures, suggesting biological evolution over millions of years. Jezero crater was strategically chosen because orbital reconnaissance revealed it was once a massive lake system. Ancient river deltas fed sediments into this lake for millions of years, creating the perfect conditions for life to emerge and flourish. The crater's geological history reads like a recipe for life. Flowing water carved channels and deposited minerals in precise layers. Clay deposits indicate periods of stable, neutral pH water, the exact conditions where Earth's earliest life forms originated. Ground-penetrating radar exposed layered sedimentary deposits extending 20 meters below the surface. These geological layers reveal cyclical environmental changes, wet periods alternating with dry periods across millions of years. Each layer tells a story of environmental transition. Periods of abundant water, followed by gradual drying, then renewed flooding cycles. This environmental stress drives evolutionary adaptation, exactly what produces the complex organic chemistry we're detecting. Perseverance has sealed 24 sample tubes containing these potentially revolutionary materials. Each tube represents a snapshot of ancient Martian biochemistry preserved across billions of years. But NASA's public communications remain frustratingly cautious. Every announcement uses identical language: organic molecules of interest, potential biosignature candidates, requiring further analysis. The disconnect between their technical findings and public statements becomes obvious when you examine the actual data. NASA's instruments have detected over 40 distinct organic compounds across multiple drilling sites. These aren't trace contamination levels. They're substantial concentrations that would indicate thriving biological activity on Earth. Some samples contain organic carbon concentrations, approaching those found in Earth's richest fossil deposits. The pattern becomes clear when you examine NASA's internal scientific processes. Their published research papers contain far more definitive language than their public statements. In peer-reviewed journals, NASA researchers describe biosignature indicators consistent with biological origin and organic preservation, suggesting biological precursors. These aren't the cautious phrases used for uncertain geological discoveries. The scientific community has quietly acknowledged what NASA won't say publicly. Astrobiology conferences now feature entire sessions dedicated to Martian biological confirmation protocols and extraterrestrial life announcement strategies. International collaborations have shifted focus from searching for life to preparing for its confirmation. The European Space Agency's ExoMars program was redesigned specifically to verify biological signatures that NASA has already identified. The Mars Sample Return Mission timeline reveals the true significance of these discoveries. Originally planned for rapid deployment, the mission has been restructured with unprecedented biological containment protocols. These containment measures exceed those used for the most dangerous Earth pathogens. Sample return capsules will undergo quarantine procedures designed for living extraterrestrial material, not geological specimens. International space agencies have quietly established new coordination frameworks specifically for extraterrestrial biological confirmation procedures. These protocols don't exist for analyzing ordinary rocks. Budget allocations show the real priorities. Astrobiology research funding has increased exponentially, with specific emphasis on biological confirmation methodologies and public communication strategies for paradigm-shifting discoveries. The Sherlock spectrometer revealed the smoking gun, aromatic organic compounds with nitrogen heteroatoms. These molecular structures represent the exact chemical signatures that Earth's earliest life forms left in 3.5 billion-year-old rock formations. But the molecular evidence goes deeper. Spectroscopic analysis reveals chiral organic molecules, compounds that exist in left-handed and right-handed forms. On Earth, biological processes create overwhelming preference for one chirality over another. The Martian samples show identical chiral preferences to Earth's biological systems. This molecular handedness is the universal signature of life. No known geological process can create such selective molecular orientation. The preservation state defies conventional understanding. Mars's perchlorate-rich environment should have destroyed complex organic molecules within thousands of years, yet these samples show pristine molecular integrity across billions of years. This impossible preservation suggests active protection mechanisms. On Earth, biological systems create protective environments that preserve organic molecules against chemical degradation. The Martian preservation patterns match these biological protection signatures exactly. Microscopic analysis reveals even more compelling evidence. Mineral formations within the samples show textural patterns identical to biological mineralization processes. These biosignatures appear in multiple independent samples across vast distances. The distribution pattern tells an impossible story. These biosignatures aren't isolated incidents. They appear across multiple drilling sites throughout Jezero Crater, suggesting not just ancient life, but an entire thriving ecosystem. Seasonal atmospheric monitoring reveals the final piece of evidence. Methane detection data from orbit shows seasonal variations that correlate perfectly with biological activity patterns. These atmospheric signatures pulse with the rhythm of life, even today. The methane concentrations spike during Martian summer and decline during winter, exactly what you'd expect from subsurface biological activity responding to temperature changes. Geological methane sources don't show seasonal variation. Multiple independent detection methods confirm these atmospheric biosignatures. Ground-based telescopes, orbital spectrometers, and surface rover measurements all detect identical seasonal methane patterns. NASA's cautious approach stems from hard-learned institutional memory. The 1996 announcement of potential Martian fossils in meteorite ALH 84001 triggered massive public excitement, followed by scientific backlash when the evidence proved inconclusive. That controversy nearly destroyed astrobiology funding for an entire decade. NASA learned that announcing extraterrestrial life without absolute certainty carries enormous institutional risks. The ALH 84001 experience taught NASA that extraordinary claims require extraordinary evidence. They're building an unassailable case before making any announcements that could reshape human understanding. But the current evidence surpasses the ALH 84001 findings by orders of magnitude. Multiple independent detection methods, consistent biosignature patterns, and impossible preservation states create a scientific consensus that NASA cannot publicly acknowledge. Internal studies show that confirming life on Mars would trigger unprecedented public interest in space exploration, or complete skepticism towards scientific institutions. There's no middle ground in public reaction to this discovery. Religious leaders worldwide have been quietly briefed on potential implications. Vatican astronomers, Islamic scholars, and Buddhist philosophers are preparing theological frameworks for life beyond Earth. The implications extend beyond science into fundamental questions about humanity's cosmic significance. NASA isn't just managing a scientific announcement. They're preparing to reshape human civilization's understanding of life in the universe. Educational institutions are already updating astrobiology curricula in preparation for paradigm-shifting announcements. University programs are expanding to accommodate the anticipated surge in extraterrestrial life research. When those 24 sample tubes return to Earth, they'll undergo the most rigorous scientific analysis in history. Hundreds of independent laboratories worldwide will examine identical samples using every available detection method. Laboratory facilities are being constructed specifically for extraterrestrial biological analysis. These facilities combine biological containment with geological analysis capabilities, infrastructure that doesn't exist for ordinary rock samples. This distributed verification approach ensures no single institution bears responsibility for confirming extraterrestrial life. The discovery will emerge from global scientific consensus, not NASA's announcement. International protocols require unanimous agreement among participating institutions before any public announcements. This consensus-building process ensures scientific credibility but delays confirmation by years. Biological containment protocols for the returning samples exceed those used for the most dangerous Earth pathogens. These aren't precautions for geological specimens. They're preparations for handling living extraterrestrial biochemistry. Sample handling procedures include provisions for active biological material. Containment facilities are designed for living organisms, not inert geological samples. These preparations reveal NASA's true expectations. Communication strategies are being developed for managing the most significant announcement in human history. Every word will be scrutinized, every implication considered before public release. Public reaction modeling suggests that confirming extraterrestrial life would trigger economic, social, and religious upheaval unprecedented in human history. NASA's caution reflects this enormous responsibility. The organic molecules in Martian soil represent more than ancient chemistry. They're messages from our cosmic neighbors, preserved across billions of years of planetary evolution. Each molecular signature tells a story of Martian life adapting to changing environmental conditions. The chemical evolution recorded in these samples parallels Earth's early biological development. NASA's careful language isn't concealing the discovery of life on Mars. It's preparing humanity for the moment when we officially confirm that life emerged independently on two worlds in our solar system. The statistical implications are staggering. If life emerged twice in one solar system, mathematical models suggest biological abundance throughout the galaxy. We're not discovering isolated Martian life. We're discovering that life is universal. If life emerged twice in one solar system, it suggests life is abundant throughout the universe. We're not just discovering Martian biology, we're discovering that the universe is alive. Current detection capabilities could identify similar biosignatures on hundreds of exoplanets within our local galactic neighborhood. Mars is just the beginning of a biological revolution in our understanding of cosmic life. Every sample tube Perseverance collects brings us closer to answering the most profound question in human existence. The evidence is already secured, analyzed, and verified. Independent analysis by international research teams has confirmed NASA's findings. The biological signatures are unambiguous, the preservation patterns impossible to explain geologically, and the distribution suggests ecosystem-scale biological activity. NASA knows what they found. The molecular signatures are unmistakable. The preservation is impossible to explain geologically, and the distribution suggests an entire Martian biosphere that thrived for millions of years. The evidence is so compelling that NASA has quietly begun preparing follow-up missions specifically designed for biological investigation. Future Mars rovers will carry life detection equipment, not geological analysis tools. They're not hiding the discovery of life on Mars. They're preparing for the day when humanity learns we've never been alone in the universe. The scientific community has reached consensus. Multiple independent research teams using different analytical methods have confirmed identical conclusions. The evidence for Martian life is overwhelming. The timeline for public confirmation depends on political and social readiness, not scientific certainty. NASA possesses definitive proof, but must navigate the complex implications of announcing extraterrestrial life. International space agencies are coordinating disclosure strategies to minimize global disruption while maximizing scientific credibility. The announcement will reshape human civilization when it comes. The only question remaining is when they'll finally say the word that changes everything: life. That moment will mark the end of humanity's cosmic loneliness and the beginning of our understanding that life is the universe's greatest achievement, an achievement we share with our Martian neighbors.